So what we'll do today is we'll first look at the 4 top level stream classes. Okay, which are the 4 top level stream classes? Yeah, I think that we had seen yesterday, right? Yesterday we saw about the 4 top level stream classes, right? So yeah, we had put those things here, the 4 top level stream classes, right? The input stream, the output stream, the reader and the writer classes. And so let's go into these 4 classes. One thing which is known is all of them implement the closable interface. Okay, and so let's now proceed. Okay, so let's start with this class called the output stream. Okay. So yeah, so what is an output stream? So output stream is nothing but if I have an object of an output stream, okay, I should be able to give bytes to this. I should be able to give bytes. Fine, it's a byte stream, a binary stream or a byte stream. Right? So I should be able to give bytes to it, and these output stream will normally have some kind of a sink where it should go. Okay, the bytes which you give to an output stream will go into some kind of a destination. Okay, see, there are going to be these. One more point here is the 4 top level stream classes, all the 4 of them are abstract classes. Okay, they have been created as a abstract class, and you will be creating the subclasses. Sorry, you may not be creating the subclasses here because there are ready-made subclasses available. Okay, but each subclass is trying to handle a different kind of a destination. Okay, fine. So what could be your destination point for a output stream? Okay, you want to put it in a file, then we have one set of classes. Okay, so you want to have the destination as, instead of a file, maybe into memory, right? Or there'll be another kind of a subclass of the output stream. Okay, so they are there for handling different kinds of destinations. Okay, right. So the various subclasses are there for that purpose. So let's first look at this top level class. Okay, right. So an output stream. See, one more thing, what we can look at in parallel. Fine. 2 things can be looked at in parallel is, one is the output stream. So we may look at output stream, as well as we may even look at and simultaneously, because they are very similar in functionality, we may even look at the class called writer. Okay, for both of them it's the same thing, right? So for both of them, yeah, they both take data and they have a destination, they work with the destination. Okay, the difference would be, in one case it's dealing with bytes, in the other case it is dealing with character type. Okay, fine. So the method to give the bytes to an output stream would be, so we have, what are the methods here? We have a method called write. Okay, parameter. Now I'm looking at it from the point of view of output stream. So for output stream, what's the parameter? You should be giving it a byte. Okay, but when we say byte, yes, our base type anyway is the int type. Okay, but it would be considering only 1 byte here. Okay, and the return type is going to be void. Okay, so we have the write method to write a single byte. Okay, when giving a byte to the output stream, that should go to its destination. Okay, fine. This method is overloaded. So instead of giving, okay, one more thing, this method here is abstract. Fine. The method here is abstract. Write method, writing a single byte, is abstract method for the output stream class. Okay, we have the write method, which would also take a byte array as a parameter. So you might give an array. Okay. So yeah, it's like writing every byte of the array into the output stream. Okay. And it's further overloaded. Fine. Where even it's not only that a byte array would be given. Right? You can say, okay, this is a byte array, but you don't want to use all the bytes from the byte array. You only want to specify a segment of the byte array, not the entire byte array. Okay, so your parameter is, you're saying, okay, this is the byte array, and from this, starting at a particular offset, okay, and so many bytes, so that's length, so many bytes, that's the number of bytes to be taken from starting from a particular offset. Okay, like if there is a byte array, let's consider a byte array here. Okay, you are interested only in specifying that these are the bytes that you should be writing, right? Okay, so then you are, one is you are giving this byte array, other is you are giving the, this is known as the offset, and this here, this size here, that's the length here. You specify the number of bytes to write. Okay. And so three basic methods are the write methods. Right? And also we have also a method called see, OutputStream and Writer, both of them are implementing a common interface called flushable. So we have this method called flush. Okay, return type void, name of the method is flush, no parameters. Okay. So yeah, the methods here are these, and then we even have a method. No, this is for output stream, okay, and then we also have the method close because it's a closable interface. Return type void. Okay, then the first method here is abstract. Right? Writing a single byte. So if you know how to write a single byte, so you know a subclass would just override the method called write. How to specify, how to handle one byte. So that would be different for different kind of a destination. Okay, so if that is done, the other things can always be done. Okay. So close will be again to release any resources which it is which it has taken. Okay, fine. But let's see now. So this is how it is for the output stream. But if you look at the writer, yeah, the difference with the writer would be, what's the difference from the writer class? Yeah, it would be dealing with, instead of byte array, there should be a, this should become a char array. Okay, fine. I'll show it. I think I'll write in the text. Okay, so if I look at the, okay, all four are abstract methods. Sorry, abstract classes. Okay, starting with the output stream. Okay, constructors. Okay, all of them default constructor. Okay, which is public. And methods, let's look at methods for output stream. So output stream methods are like this. So it has, they're all public. Abstract method returns void, name of the method is write, which takes 1 byte. Okay, But other methods are non-abstract method, return type void, write method takes a byte array. Okay, that's your array. Fine. Int offset length. Okay, we have 3 methods already. Okay, we even have a method called flush. This is because it's implementing flushable. We even have a method called close because it's closable. Okay. There's one static method here which is available. Okay, so we even have a public and static method. This method is used for just creating a what we call as a null output stream. Okay. So you get an object of the output stream. Okay, null output stream. Method name is null output stream. Okay. So this is just a output stream which is given to you. If you write there, it's not going to do anything with those bytes. They don't go anywhere. Null output stream means fine, it's just redirecting everything into null. Okay, so if you write to this kind of a output stream created using the null output stream, that method, okay, any write here will be just, yeah, it's not giving any error or anything, that's it. And you may yeah, of course, but if you call the close method, after close you should be writing. Close method means release the resources, and this stream, no other method should work on. Okay, and so this is what is for output stream. Now if I have to do for inputs for the writer, right, let's see how it is different. Okay, for writer, constructor anyway we understand is going to be like this. Methods, okay, let's look at the methods here. So here, yes, we have a public method. Now one thing here, if I write the abstract method first, okay, the abstract method here is different. It's a write method, takes as parameter a char array, okay, an integer for the offset, and integer for the length. So the method, the abstract method here is different. Yeah. Okay. Offset is within that array. So you are passing one array, but you are asking, no, don't use the whole array. From the array, starting at this offset, okay, index position in the array, yeah, zero-based index position. Yes, zero-based index position in the array from where the bytes need to be picked up or the characters need to be picked up. Okay. Fine. So returns void. Name of the method is write. Okay. So once you know how to deal with one entire segment of a character array, then yes, it can be translated for array also. Okay, or you could do it for write method for int, which is one character. So it considers that int as a character and then it will be used. So 3 methods for writing here also. Okay, but okay, there are a few more things. Oh, there's one more thing about writer. Okay, writer implements the appendable interface. There is an interface called appendable. Okay. So we have one interface called appendable, and it has got 3 methods called append. Appendable interface is also implemented by. Okay, so appendable is this is mainly much closer to the more to do with the char sequences. Okay, so it's also implemented by the string builder. Okay, there's also a class called string buffer, char buffer, sorry. Okay, char buffer, string builder. Like string builder, there's also a string buffer. Okay, so these are other classes which also implement the appendable interface. Okay, fine. Okay, I'll put methods for appendable. So it's implementing appendable, and because it's implementing appendable, yeah, there are some methods from the appendable. Okay, public method. So this is methods from appendable. Okay, public method to return. The method would, instead of return type being void, where the write method says return type is void, it's like a write method only, but returns the object back to you. So writer object will be returned. So you can have, you can say append this dot append this, right? So you can continue and have subsequent. So the method name is append, returns writer, method name is append, and it can append a single character. Okay, it deals with character, or you may append a, instead of a character, okay, you can specify a char sequence also. Okay, and a char sequence, or here you can also give the now instead of a segment, here it is saying integer start index and integer end index. So here it is in terms of so the start here is like that offset. Okay, but the second parameter, the last parameter here is the end offset, end index position. In other case, it was the number of bytes. It's not the last parameter is not number of bytes, but the number of the index position of the last character. But this is not to be included. Okay, it's excluding up to end, but not including the end. Not including the end. Yes. Yeah. So for example, if you say 2 comma 4, okay, so 2 3, not 4. 4, the end is not included. Okay. Okay. Right. So we have these append methods, other methods. Fine. There are other methods also. So these are because of appendable. Right? 3 forms of append method, and the other methods here are like this. We have also another form of a write. Okay. Since it's dealing with text. Okay. So here you can say, okay, the method return type is void, name of the method is write, and the parameter here is nothing but your string. You can specify a string, or you can specify integer offset and integer length. Okay, right? So segment of a string, instead of a char array, just like char array, you can use a string. Okay. Other than this, yes, we understand method from flushable, flush and the close methods. Okay. And we can just copy from. Okay, these methods are always going to be there. Flush and closable, flushable, closable, and those interfaces. Okay, we even have a static method here also. Okay, public static method to return a writer. Name of the method is null writer. Okay. A writer which just consumes the data which you give, nothing happens to it. Right? Sometimes you might need it for testing purposes. Okay. Fine. Okay, so this is for the output side, the base streams, right? Write method and the fine. It's basically based on the write method, giving data to a stream, and that goes to some destination. Okay. Fine. Coming to the other classes, the other direction is the input direction. Okay. Fine. So the input direction is going to be something like this. Okay. And so that was for this. Okay. Now. So if there is, now we are dealing with the input stream and reader. Okay. And there are two classes, input stream and the reader. They are also abstract classes. If it's an input stream or a reader object, right? Then if you have such an object, they have some source from where the data will be fetched. Okay. And then you can say, okay, you have the read method to read from this. Basically, the direction is like this. Okay. So here will be the method. The base method here is the read method. Okay, reading data from the stream, fetching data. Right? So here you should be getting data from this. Okay, so let's see what are the methods in this. Right? Okay, so now comes the, let's start with the input stream. Okay. So input stream default constructor will be there and the methods. Okay, so we have the methods like this. Public method, read method, right? So it should give us data. Okay, so it returns int. Return type will be int. Though the return type is int, here is the read method without any parameter. Doesn't need a parameter. So this is for reading. Okay, this here is the abstract method. Okay. Single byte. Okay. So what's the value which it is returning? What's the range of the value? When I say byte, right, here it should give you a value in the range from 0 to 255. Okay. Return type is int. Okay. Fine. -1 for end of file. When there are no more bytes, it returns a -1. Yeah. Okay. So read, if it returns -1, it means end of file. Okay. Fine. Then we even have the methods like this. Public method, return type will be int. Read method is overloaded. You can specify an array. Sorry. It would be a byte array. Fine. Fine. So what does it do? Reads how many bytes? Reads so many bytes, right? And fills the array. One thing here to note here, these read methods are blocking methods. They have to fetch from some source. If that source is a device, maybe a slow device or whatever, fine. Or if say for example it's a keyboard, and then it all depends on how the user is behaving, right? Whether the byte is available or not. So it will have to wait till someone gives a byte. Okay, till the byte becomes available. Okay, right? So if you are typing from keyboard and if you want to indicate end of file, okay, on Windows you have to put a Control Z. On Linux it would be Control D. Okay, fine. Well, see, if it's accepting and reading, the program is trying to read data, right? So from keyboard, if you want to put an end of file, that's how it is done. Fine. So many bytes, fine, till it encounters a end of file or what, right? And it returns, what does it returns? So if it encounters end of file in between and could not fill the n number of bytes, then it will fill whatever it can, right? But when end of file comes, right? So then it has a count, how many bytes I have filled up. Okay, so it returns that. Okay. So it's filling the array, and fine, it's not doing anything, but just filling an array. You need to pass an array. So it's like your buffer in which it will put the bytes which it is reading. Okay. Fine. So another method, yes, what's the other method? You can specify a array, an integer for the offset, and an integer for the length. Okay. Fine. So this read method, yeah, what does it do? The difference here is from the earlier method is that it doesn't disturb the whole of the array. Okay, it will fill in this array and it will read only up to length number of bytes up to this. If it can't read, if it encounters an end of file before this, okay, fine, then it will just say how many bytes it has read. Fine, that's the number of bytes which it could fill in the array. Fine, it's not going to disturb the entire array, only these many bytes in the array. This segment of the array will be filled up. Okay, fine. So these are there initially. Subsequently, okay, in version 9 or 11, it added another method, okay, where it would return type is int, or input stream will have to, I think it is int. We have the method called read all bytes. Read all bytes. Right? So what does it do? Oh, here, sorry, the return type is a byte array. And so what will it do? From whatever the current position is, right? Because it may have read earlier also from this input stream. Okay, so till it encounters end of file, everything will be picked up and put into a single byte array. The length of the byte array will be the number of bytes which are remaining. Okay, and that's what is returned. So it collects all the bytes from this byte. Okay, we even have a method called, instead of saying all the bytes, you can say read how many n bytes. Pass that n as a parameter. Okay, you want to read so many bytes. Okay, for some reason they have also put one more read n bytes, where it is just like the earlier read method. It's just like that earlier read method. Only thing, the method name here is read n bytes. Okay, when all these reads are going to be blocking reads. Okay, so we have these various forms of read method. Okay, okay, and so reading. Sorry, one more thing here. The return type is not byte array, but it is int, because we have already given the buffer where to fill. Okay, so yeah, it matches the same as that read method earlier. Okay, so this matches this one. Method name is read n bytes. Okay. Right. We okay, what else we should be having? So now if you are reading, okay, one is read method, fine. We even have a method to return long. Name of the method is skip, where parameters are long, the number of bytes to skip. So what is a skip method? what should it be doing? So how will it skip? The basic implementation which is available is to just use the read method so many times. It's just using the read method. A subclass is free to override and give an efficient way of doing it. Okay. Otherwise, yes, the basic implementation is to use the read method. Okay. So we have skipped again. This has been overloaded, not overloaded, but again they have called skip n bytes. Okay. Doing the same thing. Okay. Okay. So read then skip. Okay. We have the method. Okay. We even have a, see, this is a blocking, and these read methods are all blocking, right? They have to wait till something is available, right? So we even have a method to return int. Method name is available. Okay. Okay. So it returns the number of bytes. Okay. So number of bytes which can be read okay, without being blocked. Okay. So how many bytes are readily available? No blocking will be needed. Okay. So that's a available. Okay. We even have a method public void mark, and you pass as parameter mark limit. Not mark limit, we call it as the read limit. Yeah. Okay. So what does mark method do? It's just like placing a bookmark here. You want to remember this current point. Okay. But there is a parameter which says read limit. See, if you are remembering, that means you would like to come back here sometime. Okay. It's like, while you are reading a book and someplace you find something is interesting, right? You might place a bookmark there, and then you may read further and further, and then come back to this bookmark. Okay. So if you want to come back to this bookmark, okay, so we have the method called reset. So reset method takes you back to the last marked position. Okay. Last time when you called the mark method, fine, what was the position? So go back to that position. Okay. Now there is a read limit. The read limit is after calling a mark, fine, I can remember this bookmark till you read so many bytes. If you read more than the read limit, I'll forget the bookmark. Okay. Mark will be forgotten once you have read more than the read limit. Okay. See, implementation would be when you call mark the read limit, or it may allocate an array of that size, right? As you call the read method subsequently, okay, it would also put it in the read or skip, whatever you may be doing. It will just keep on filling it in the array which is according to the read limit. If it becomes full, I'll forget the mark. Okay, reset. Okay, I'll start giving you those bytes from the array now. Okay. And keep it someplace. So when a buffer may be allocated when someone says mark. Okay, that's just suggesting an implementation. Now this kind of a thing, that is mark and reset, right? That's a pair of methods. These may not be available. This implementation of this some of the input stream may not even support this. Okay, so we have a method to check if this thing is supported or not. Not supported. Okay. Yeah. Fine. Yeah. And we even have a method, public method returns. Yeah, we will have close method because it's closable, but we even have a method, return tab. I'll have to check it. It might be void. Name of the method is transfer to, and the parameter is an output stream. All subsequent bytes, okay, just transfer all of them into this output stream. It's like reading from here and writing to the output stream. Read from this input stream, write to a given output stream. So transfer to, right? So transfer to this output stream. This also is actually a subsequent addition. It's probably in Java 11 or something around that. And of course, we have the method called close. It's closable, so there's a method called close. Okay, fine. So input stream is going to be all such methods. Fine. So you should be able to fetch, ask it to fill in an array. Fine. You can skip. Fine. You can ask it to remember a position, subsequently come back and read again. And read the same thing as again. And if you say reset, you are going to read the early starting from that position again. Okay. And transfer to available, just to check if things are available, so that your next read, how many bytes you can read without being blocked. So you may allocate an array of, calling a read method where you are passing an array. So you know how much array size to allocate. Okay. But remember one thing, what it also mentions is when you say available, and it's at that moment what is available. Subsequently, when you are calling the read method, maybe more bytes may be available at that time. Right? So that's from the input stream, but our input stream is also very similar to reader. Okay, let's see. So most of these methods, okay, yeah, one more thing. Here also we have a static method to return an input stream. Name of the method is null input stream. Okay, so what is this input stream which it is returning? For output stream, you understand, just uh, like uh, just discard any bytes which is being returned to it. So it works all the time. But this input stream which you get as a null input stream, if you call the read method here, it immediately says I am at the end of it. Okay, but it's just like an input stream which is at the end. There's no data in this. Okay, so that's a null input stream. Okay, which can be created by using the static. Okay, let's look at the reader class now. Okay, methods again for the reader methods. Here again the abstract method was the one for single byte, but here, okay, reader, I'll also mention one more thing. It also implements an interface called readable. Readable is part of java.lang package. Even they're appendable when we looked at in the writer class. That's in java.lang package. So reader from the readable is from the java.lang package. Readable has just one method. Maybe I'll put the method here. Okay. So readable has a method, public method, returns the readable. Okay, so in this case, it's the reader it will be returning. Name of the method is read, and parameter is a char buffer. Okay. Fine. So it's a buffer. This buffer is what it has to fill. There is a class called char buffer, which is from the java.nio package. Yesterday I was just trying to mention about the buffer being used in the NIO. And basically, what we have in NIO, okay, just a little bit about the NIO. Okay, we have the buffer as a class. Okay, and then there are subclasses. So buffer class is like, okay, if it's just one object, it is normally backed by some kind of an array, some place which is having data. So it has something like, okay, to deal with moving to any particular place within this, okay, within the buffer, you can jump to any place. You can then start filling in the buffer. So you can just say, okay, so it will then be able to remember. It has a current index position basically. Okay, fine. What is its current position? So that position also can be changed. So methods where the position in the buffer can be changed. You can mark. Okay, so it will have a mark. So it's something like 0 is less than or equal to the mark, is less than or equal to the position, is less than or equal to the limit, and is less than or equal to the capacity. These are some kind of things managed for a buffer. In the java.nl package, there is a class called buffer where these kind of things are managed. Okay, these values are going to be managed. Okay. So someone says, I'm reading into a char buffer. Okay, now the buffer has subclasses. The buffer class has the subclasses, which are the byte buffer. Okay, except for the Boolean type, all the primitive type buffer for them. So we'll have the byte buffer, the char buffer, int buffer, long buffer, and so on. Okay, except for Boolean. And so we have buffers for other types and primitive types basically. These buffers are only for primitive values. Okay, so there is a capacity, there is a, I think, limit or size. Yeah, there's a mark and there's a position. Okay, fine. So we have methods to manipulate these and jump around, right? The position can be changed to the mark. Position cannot go beyond the limit. Okay, you can set a limit in the buffer. So if someone is saying, I want to read into the char buffer, right? That's what this one is saying, right? So in that char buffer, whatever is the current position, from there it will start filling right up to the limit. Okay, so that's the number of bytes it's number of characters it's going to read and fill. It would be a char buffer in which it is reading. Okay. And there are many other methods like get and put. Those kind of methods are there. So they put in the current position or in a specified position also. So various methods are there in the buffer. So I'm not discussing buffer from java.ni currently, but just to give an idea what that readable deals with a filling into a char buffer. Okay. Fine. So we have the now the other read methods. Yes, we have the abstract method. Return type would be int. Similar to, now these are methods very similar to the input stream. Okay, yeah, I can pick up from there. Okay. Okay. So only thing to change would be here, the things to change. This one is, if I keep in the same order, this one is not the abstract method, but whereas this one is the abstract method. Okay. And it won't be a byte array, it would be a char array. Okay. So one difference, yes, is about the abstract method being the one with the array of certain length. That becomes abstract. Okay. Yeah, of course, here we don't have these because these were the things which were added later. And so these methods are not there. We have the skip method. There's no skip n bytes. Oh, instead of a method like available, we have a method called ready. It can't tell you how many characters are there. It's about reading characters now. So it can't tell you how many characters are there. Okay, fine. But it can always tell you whether there are characters or not. Some characters are there or not. Okay, fine. So at least one character is there. Then this will be returning true. So this one returns a boolean. Sorry, ready returns a boolean. Ready method returns a boolean, whether it's ready with the data or not. Okay, mark and reset work in the same way. Mark supported is there. We have the transfer to method where you can specify a writer and then the close method. So that's what the reader is. Clear about the four classes like this, right? Okay. Writing, OutputStream and the writer class. Reading, InputStream and the reader class. Okay. Okay. Fine. So fine. The next thing then fine. So this is one thing. Okay. This is the abstract